Today we're gonna have a look on how to make this proprietary serial cable here, what one can use in order to actually reset one of these APC power distribution units. Namely, this thing here is a somewhat proprietary serial connector. It's in one side it's an RJ12 jack, and then on the other side then you're gonna have a DB9 female serial connector here, and then this can be used to reset the password. I made this cable for myself because it's actually quite expensive to buy it. It's mostly available from the US, so the delivery itself is quite expensive. And the thing is that, as an example, if you are taking your Cisco serial cable, I mean this rollover cable here, you know, when you are hearing about the serial port, you are just like, okay, fine, we're gonna plug it in, we just reset the password, and it's like, oh no, this is not going in. Then the thing is that this here is an Ethernet port, so yeah, don't even think about putting your serial console in here. It ain't gonna work, even though it physically fits. So yeah, this is why I'm making my own connector, and if you follow this tutorial, which is quite detailed, then you should be easily able to make one of these cables for yourself, and also to learn a little bit about how to crimp different connectors and what to take care of. I'm gonna show some of these nifty tricks which might help you out later as well. Now, the components and tools what you will need in order to make this proprietary RJ12 serial cable, well, then you're gonna need about 1.5 to 2 meters of Cat5 cable. I chose Cat5 because, first of all, it's cheap, it is readily available, and also this is not Cat5e, this is just Cat5, so it is actually a rather thin cable, and since it is thin, it will nicely fit in an RJ12 socket. Okay, so when we crimp it down, there will be no problem with the overhang, because the RJ12 is actually smaller than the RJ45. Then, of course, as I mentioned, then you're gonna need an RJ12 crimper. I mean, most of the time it's the same for RJ12 and RJ11. You're then gonna also need a DB9 serial female connector, which I prefer the one which you can solder the leads. You can also buy the one where you can have also a specialized crimp tool for them. The crimp tools are really expensive, and I have a soldering station, so yeah, I mean, it's easier for me to just simply solder the leads right directly to the connector. Then you're gonna also need a plastic housing I bought for the DB9 connector, or even though it looks metal, it's actually plastic. And also you're gonna need then these metal pieces which come normally with this housing. So you can then build nicely this connector into the housing, and it looks like a half professional job. Now, regarding the pinout of this proprietary connector itself, luckily other people have already measured and traced out that which pin is supposed to go where, and I just looked it up online. Actually, I found in different references different type of pinout. So in order to make sure that at least they are based on some good assumptions, I traced out, and pin number 5, which is here, and then pin number 2, which is then here, they are both going to the ground. And actually, if you measure here as an example on these screws, then you see that indeed there is practically a 0 ohm resistance between pin number 5, pin number 2, and the chassis itself, which is at the ground potential. On the RJ12 connector itself, if you are viewing it from the front, and then this plastic tab is down, then this pin on the right hand side is pin number 1, and then you go towards pin number 6, so this is pin number 6 on the left side in this configuration. And then let us of course make now this serial cable, and since there are only 6 pins anyway present here, in fact we know that 2 of them are common and ground, then first of all we're gonna make the most simple connection between 2 serial devices. This most simple serial cable is a so-called null modem cable with no handshaking and no flow control, at least no hardware flow control. Well, I mean, the thing is that we haven't discussed yet of the serial communications, at least I haven't made a video on it. So yeah, I mean, just bear with me, I will just explain which pins goes where. And actually that is gave me an idea that I should do a series on the serial communication itself, since it is used all over the place, especially if you are doing a Cisco curriculum, you have to know about the all type of serial communications. So I'm gonna definitely start that series, but for the time being I just give you the pin numbers on the RJ12 connector here and on the DB9 9-pin serial port connector, and yeah, we're just gonna test the cable without really, you know, taking care of what are the signals doing. In order to make the cable, then take your RJ11 or RJ12 clamp tool. Normally you have here a blade which is used in order to take off the this plastic from the Cat5 cable itself. You can also use this blade because, as you see, when you completely close it, it's actually not fully closed. So this is why most of the time this blade here is actually used to cut the wire, and then this is used to take off the shielding. But since we are not working here with telephone wire but with Cat5, we cannot really fit it in here, so that's why I'm actually using this side. So you just gently push down, and you don't want to cut the wire, so that's why you just slightly rotate this wire inside, so then you're gonna scorch the housing. As I said, after you have just scorched this plastic housing, then you can just pull this whole housing down of the cable, and now you have the 4 pairs exposed. Now this cable is then containing 8 cables inside, individual cables I'm referring to, or 4 pairs which are twisted together. The thing is that for serial communication we would not need to have twisted pairs, but as I mentioned, this cable is just dirt cheap and easier to get, and this is why I'm using this. Otherwise you could use any other cable, it would work just fine. Furthermore, it actually fits inside this RJ12 connector when you push it in order to try to crimp it down, and that is important because that gives a bit of mechanical stability for the cable, you know, when you are yanking on it, that it doesn't just pull off, because that would be no good. Then here is now the cable without this Kevlar to make our life easier. And the thing is, as I mentioned, that we're gonna need maximum 6 cables for this RJ12 connector. Here we do have actually 8 cables because we have 4 pairs, which means that we're gonna have to cut off 2 cables. And at the beginning, as I mentioned, I'm gonna do the very minimal connection, meaning that I'm gonna use only 3 wires here. But in order to increase the mechanical stability, I will still crimp in this side 6 cables into the connector itself, and on the other end I will just simply not solder it on the DB9 serial connector. And then of course one can then think about it, how to decide what cables to cut or what cables to leave. So then I think it's more easier to choose those colors which we can see most clearly. So I don't know how good this comes through the camera, but personally I'm gonna pick this green one as an example, then I'm gonna pick this orange one, and I'm gonna pick this brown one for the 3 main wires. I'm gonna crimp down 3 more wires as well, which are then the equivalent wires to these pairs, so meaning that the white orange, the white brown, and the white green as well. But as I mentioned, they will not really be used for the electronic connection, they will just give the mechanical stability itself. In the next step, then you just untwist the twisted pairs to have more easy access to them, and then you pull on them slightly to straighten them as much as possible. Here are then the 4 pairs untwisted. As I mentioned, we're gonna have to cut off 2 cables because we need only 6 for the connection, I mean the mechanical connection itself. And that means that I'm gonna cut off now these 2. It doesn't really matter which one you cut off, but I'm gonna cut off this bluish pair because it's really hard to see, especially on the camera, so I'm gonna get rid of these 2. In the next step, then of course we would like to then put these cables inside the RJ12 connector in a relatively nice pattern, because we need the specific 3 pins to match. At least I would like to have this orange, then the brown cable and the green cable. And in order to do that, one can use a really cheap trick, and this trick is to use a paper clip, which then you can use to stick the cable in, I'm gonna show you in a moment, in the pattern which you desire, and then the paper clip gonna hold the cables in that pattern, because I can tell you that the wires are rather stiff. So if you normally hold it by hand, it really takes a lot of time and fiddling around. So I find this trick really useful both for making RJ45 or RJ11 and RJ12 connectors. It really works and it makes your life a lot easier. The main idea behind this paper clip trick is that first you just align the cables as you want to have them, either with your thumb and your index finger using them, or you can even put in individual pairs inside the paper clip. But anyway, once you have it, then you can just nicely slide the paper clip over, and now you can release the actual cables, and they are not bending all over the place, because if you actually try this, or if you are doing such connections, you know as well that the cable is really stiff, so it's just gonna spring back as it wanted to be. And this is why it's good to use this paper clip to then hold it in place nicely, so that we can check whether we have the right cables in the right places. In this connector, the three most important pins are pin number 2, for which I'm gonna then use this green cable. So this is gonna be the ground. Then pin number 3 here, for which I'm gonna use this orange cable. This is going to the receive end or the receive pin of the DB9 connector. Then next to it, this brown cable, this will then go to pin number 4 of the RJ12 connector, and that is going to the transmit end of the DB9 cable. And then, as I mentioned, I'm gonna use this orange white and brown white and also this green white here, just to provide some mechanical stability inside the connector itself. And also it might be that we need these pins in order to provide some minimal hardware handshaking. I really hope that we can get away with that. In the next stage, we have to cut then the wire leads here to the length. And as you see, this is the time when this paper clip thing is really helping a lot, because now we can see that roughly this is exactly the length how we have to cut the cables here. Okay, so we can really, by pulling it back on the cable and bending it a little, we can even use it as gauge of where we're gonna cut the actual wires. And then in order to cut the wires, then you're just gonna grab the crimper tool, and then you're gonna place the wire in the groove where it cuts the cable. So as you see, if I close this, it's completely closed, so it will cut the wires. And then I can just cut the wires to the desired length. So then here we go. And then, as you see, I still have the wires nicely sorted inside the paper clip, so I don't have to rearrange them again. And I know that also I cut them flush, because that's, you know, the metal gave me the direction. So that's why I really like to use this trick to make my life easier. In the next step, then you're gonna take the connector, then you take care of the right orientation. So as I mentioned, this is then here pin number 1. I wanna have pin number 2 as the green cable, so that one. So this is where I will align them. Now you really need to hold here tight on this plastic housing, because one need to then remove now the paper clip, and you don't want to have the cables flying around in all directions. And then you just push the cable nicely into the RJ12 case or the connector itself, and as you see, it nicely went in. There is no need to hustle with it, which, as I told you, if you don't use this paper clip trick, I mean, the same job, it's gonna take you at least 5 to 10 minutes longer. At least it takes for me. I mean, this way it's a lot easier. After you have pushed in the cable, then you really need to push the housing in, so that it is well below this plastic groove here. I don't know how well you can see it on the camera. So you see this triangular shape here, which is missing from the plastic. So this will be actually pushed down by the crimper tool itself. So then this will be used as a mechanical release on the cable, so we cannot yank it off easily. And then, of course, the main thing is that you also visually inspect that all the cables are on the right locations. And after you are done with that, inspect it also from the side. I don't know how well you can see it due to the reflection on this plastic, that the cables are actually right here, nicely at the very end of the connector. Which is so far looking like a good job. So that's what you need to achieve, because these small teeth here made out of copper will then be pushed in. So you see these copper thingies, they will be pushed in and they will then cut off automatically due to this mechanical force what you apply with the crimper. They cut into the insulation and they make electronic connections with the underlying wires. After you have visually inspected that the cable is seated right, now it is then time to actually crimp it down. So it means that at this stage there is no turning back. If something is wrong, you need to cut off the connector, you need to throw it away and do this procedure again. So yeah, that's why it's better to visually inspect it before you actually crimp it down. For the crimping itself, then you just take the tool, then you look up where is your RJ11 or RJ12 crimping, this profile on it. I mean, this tool can do only 11 and 12, but there are combined tools, as I already mentioned, which do several multiple types of connectors, so that's why it's good to check it. And then you just plug mechanically the connector into this port where it then fits, or this slot in the steel. So here you go, it's plugged in. Take care that you are pushing on the housing, and then you just push down on the crimper tool with quite a lot of force actually. This is not a ratcheting tool, so you don't hear, this feedback, how much force you apply. So I just crush it, then release it, and then don't pull the cable from the cable itself, because sometimes you didn't crimp it fully. So yeah, push it through with your finger. And this pushing through, is because that way, if you didn't fully crimp the cable, there is still a small chance that you can just visually inspect it, push it back in, and then push down again on it and hope that things gonna work out on the second time. But anyway, don't forget that you actually need to push this release ear of the connector first, because it really latched into this metallic shape. And once you push that release latch, then you can just nicely push it through with your finger, and then you can pull it out. Come on. Okay, and then as I mentioned, don't pull on the cable yet, just inspect it first whether there is a good job done on the crimping. So if the crimping went well, what you will see is that now these metallic teeth are actually protruded inside the plastic. So if you look at a connector which is not yet crimped, they are actually about a 0.5 millimeter on top of the plastic, and now they have been pushed down. That's first of all for the electronic connection. So what you could see, but I cannot zoom in that much with my camera without causing reflection on the connector, that actually these small teeth really cut into the cable. So yeah, now they are making electronic connection. And the other thing to check is that this larger plastic here, this triangle, is actually pushing down on the housing. So this big thick plastic here of the cable. So it means that even if we pull now with a bit of force, we're not gonna pull this thing off, which means that we have done a good job. Now is then time to start working on the other end of the cable, where then we're gonna then solder the DB9 female serial connector here, which we are then be able to plug into our serial port of our PC or into a USB to serial port, and that way then we can communicate with the APC PDU. In order then to have access to the other side of the cable, then I'm gonna use the same tool. So with the crimper tool, I'm just gonna cut off the plastic housing of the cable and letting about 3 centimeters or 2 centimeters of the wires themselves exposed. As you remember, we have cut off these blue and blue-white cables from the RJ12 connector side because they are hard to see. This means that they are not connected to anything, so we're gonna get rid of them here as well, in order to make our life both easier and to prevent, human mistakes of soldering the wrong wires to the connector itself. Then we're gonna just untwist all these cables here. And then now is the time to solder this cable to the DB9 connector. And as I mentioned, we're gonna solder only 3 cables at the beginning and hope to get lucky. So let's go. Regarding the pin numbers on the DB9 serial female connector itself, normally they are actually printed on right next to the pins. But if you don't have eventually printed them on the plastic casing, then anyway, so this is here then pin number 1 as you look at the connector itself. This is pin number 5 here on this corner. Then it goes to this corner. This is pin number 6. And here, this end is then pin number 9. So the thing is that since we are using only 3 wires here, then we're gonna be using only pin numbers 5. Then we're gonna using also pin numbers 2 and 3. And the rest then will be fully unpopulated, at least at the beginning, and if it works, then that's how I'm gonna leave the cable. So then on the DB9 end, we then just gonna need the green wire, okay, the orange wire and the brown wire right here. So these 3. And then the other 3 wires, for the time being, I just bend them back so they are not in my way of soldering. Then in the next step, I'm gonna remove about 1 millimeter of the plastic from the very tips of the cables, and then I'm gonna tin them with a little bit of solder. Here are then the 3 wires tinned, and actually I have cut off a little bit from the wires. They were too long, because this thing will be then mechanically fixed inside this plastic casing for the DB9 connector. And as you see, this is the place where the screws will be then holding down this wire. So yeah, it would be good to have, the plastic casing then at this place where it will be held down by this mechanical force here. So it is not so easy to pull it out, and we still have enough slack to actually solder down the DB9 connector and to make connections with it. So you might remember that on the RJ12 end, the pin number 2, which is the ground, I used for that the green wire. So then I'm gonna solder here the green wire to the pin 5 of the DB9 serial female connector. So then I just place then the green wire to pin number 5 of the serial connector here. It's actually a hollow pin, so it's really nice. I can push the cable in, I don't have to hold it by hand. Then I just take the soldering station and then hit it with the solder. Next, then I'm gonna solder pin number 3 of the RJ12 connector, which in my case I use this orange wire here for pin number 3. So then this will actually come to pin number 2 on the DB9 connector, and this is because we are setting up here a so-called null modem configuration. As I mentioned, the whole idea and working principles of the serial communication will be then the topic of an upcoming video series. So yeah, anyway, so then just, you know, practically we are just making a crossover serial cable. Yeah, that would be the easy explanation. So this is why I'm connecting pin number 3 here to pin number 2 here on the DB9 connector. After then the orange wire is then soldered, now it's then time to solder pin number 4 of the RJ12 connector, for which I use this brown wire here. And then on the, so this pin number 4 from the RJ12 will actually become pin number 3 on the DB9 connector here, because again, as I mentioned, we are doing this crossover configuration. Then as you see, all 3 electronic connections have been made. So then we have then here the ground, then we have the transmit and receive pairs then crossed over compared to how they came out of the RJ12 connector. And then actually at this stage you should be able to test this using your APC PDU. So then I'm gonna plug this thing into my PC, this into the PDU, and hope to get then a serial console connection going. Actually at this stage, if you have a multimeter, it's a good idea to trace it out whether all the connections are fine. I mean, I traced it out already and things are looking good. So with the continuity meter, most probably you know you can just easily have the tone function, so you don't even have to look for, you know, which what you are doing, because you can clearly hear when you have a connection made. Now before I test this serial cable in my PC, I actually plug it into one of these really broke down serial breakout cables which I made about 2 or 3 years ago. And I can tell you, making one of these breakout cables is really useful, because you can really, you know, visually inspect the signal even before you plug it in. And in this case, as an example, we can clearly see that here this LED is green, which in my setup means that on the pin number 2 there is a minus 12 volt asserted, which is completely fine, because you remember we are doing a crossover cable or a null modem cable at the end of the day without any hardware handshaking. This is why none of the other LEDs are being lit. And the minus 12 volt is always, you know, the pin is normally at minus 12 and then suddenly jumps shortly to plus 12, which is the so-called start bit. So yeah, this is why this LED is then telling us that this cable got a chance to actually work with my PC. And in the tutorial series on the serial port, I'm gonna make an actual newer version of this breakout cable, because I can tell you it's really useful to debug and repair, you know, routers and switches and so forth when you have an issue with the serial connection. I have tested it, and luckily the cable works fine, even in this really basic null modem configuration without any kinds of handshaking. So there are really just 3 wires connected to the serial port here. And I did manage to actually reset the password. This is what I will show you then next. But first of all, then let us make this connector look nice and shiny. So then really install it into this plastic case. One could of course snip off these extra 3 cables, but since I don't know whether in the future eventually I might wanna still implement some hardware handshaking, I'm just gonna let them hang around there, no problem. So then we just install these small metal retention brackets, which normally come with the plastic casing for the RJ9 connector. And for that, then they provide 2 shorter screws here. So for comparison, the other screws are these ones, which are longer, and they are used to actually hold together the 2 halves of this plastic case for the connector itself. And actually these sort of U-shaped metal pieces are made such that one of the holes is somewhat larger, so you can just push the screw right through it, but the other screw hole is actually made such that you then have to screw in the screw inside. So that's how they are getting away without actually using the equivalent screw for the other side. Here now then we have these 2 U-shaped metal retention brackets then loosely screwed onto the cable housing. So you can then take the actual plastic housing for the RJ the DB9 connector itself. So practically you're just gonna take this plastic casing, 1/2 of it, then you're gonna push in this DB9 connector, and actually the DB9 connector will be right here. So this metal plate here will be then stuck here. I mean, mechanically, I must say it's not the most stable, but hey, that's how the housing is made. So then, yeah, that's practically how it looks. Okay. And then you're then gonna push these U-shaped metals such that they fit here. So practically these are the 2 screw holes to hold together the 2 halves of this plastic casing, and then you have then these metal thingies fit in there. And once you have that, now you can really tighten here these 2 screws, because now you have the actual length for the cable inside. So after you have these U-shaped metal pieces are then nicely tied and the DB9 connector in place, then optionally you can put in these screws which have a small retention groove on them, and then these will come right here. Okay, so these can be used practically to screw the DB9 connector into the equivalent connector on the PC. I mean, I don't really like this type of screw, because normally you would like to screw it in with your hand. I mean, this one can be only screwed and unscrewed with a screwdriver, but yeah, I mean, we got the screws, so I might just put them in as well. And yeah, because of the groove, then you cannot then pull them out, okay, from the plastic. And then you take the other half of this plastic casing, and you just nicely push it on top such that nothing falls out, hopefully. Yeah, here we go. And next, then the two longer screws then gonna go through these two holes here. Okay. And then for these, you're gonna have to actually use these small screw nuts on the other side and then screw them in to screw the two halves of this plastic casing together. Finally, then we are done with this proprietary serial cable. So then this is the RJ12 end. Then here this is the DB9 female connector what you can plug into your PC. And yeah, now it's time to go and actually reset the password on this APC power distribution unit.